accelerometer actually reads the acceleration of the device, and the magnetometer looks for the angular velocity in different direction x, y, and z. And the magnetometer also looks for the magnetic field in the area. It could get noise easily by any magnetic field near the sensor. But in general, the readings that we're gonna have from the inertial measurement unit is the acceleration in 3-axis, the magnetic field in 3-axis, and also the angular velocity in 3 different axes. At the moment, there is 2 stages of programming. First, the hardware codes that need to be sent to the devices, and the devices need to get programmed before the data collection. For that specific part, we use an Arduino software, because we're using the Arduino processors basically. And in that section, the programming needs to be done with all the communication stages and all the definitions of the different number of sensors, for example, which one indicating to the tire data, which one indicating to the shank data. But there is also another section of the programming which refers to the post process. This is the raw data we have from the patient in the form of CSV. Later on, this CSV file will be sent through a script, a MATLAB script, and they can be used in the stage of filtering and cleaning of the data through the pre-process stage for filtering in case of any noise or drift. Once the data capture and normalized and get filtered in case of any noise or drift, they will provide the angle of the movement of the thigh, shank, and foot at the same time. And for example, here in the code you can see in different loops, if loops or for loops, for doing some calculation on the raw data from x-axis, y-axis, or z-axis in each of the accelerometer, gyroscope data. And finally, once the calculation done over the data, the MATLAB will provide us some signals. Usually for a normal type of gait pattern, the foot and thigh and shank, all of them should have positive and negative peaks in different cycles of the movement. But for example, in case of any disabnormality, for example in foot drop, the dropping of the foot happens, so one of these sharp negative peaks gonna be missing from the gait pattern and provided whole different gait pattern from that subject, and that's where we can find out the disorders or abnormalities. This data will be helpful for monitoring the recovery procedure of the patient as well, not only for identification of the symptom, but also for monitoring the patient after the surgery and the improvements they have through this procedure.